On this video, you will learn how to illustrate finite and infinite geometric sequence. Let us deal with our first example on illustrating finite and infinite geometric sequence. So for our first activity, we will be identifying the first term, the common ratio, and the last term, and number of terms of this geometric sequence. So what is the first term? So obviously, we have our first term, which is 64. The common ratio, we can get that by dividing. We can have this 2, which is 16 divided by 64. Okay, the lowest term it, so we have 1/4. Or simply 16 getting the common factor between 16 and 64, which is 16. 16 divided 16 is 1. 64 divided 16 is 4. We can also use this 2 so that hindi na tayo maglo-lowest term. We have 1/4. So that's it. Last term. So this 3 indicates infinity. So the last term, we don't have last term. Number of terms. Of course, infinity, you cannot count it. So cannot be determined is the last term. Number of terms cannot be determined. Alright? Since we can only determine the first term and the common ratio of this sequence, this geometric sequence is an example of infinite geometric sequence. Let's move on with our next example. Let us try to identify the first term of this geometric sequence. So the first term is 3. What is the common ratio? We can divide this 2, which is 6 divided by 3, which is 2. So the common ratio is 2. The last term, of course, is 48. How about the number of terms? So on this case, it's countable. We just count 1, 2, 3, 4, 5. So the number of terms is 5. So this sequence is an example of finite geometric sequence. Since it has first term, it has common ratio, and of course the last term and the number of terms. So if all of these are present, it means that this one is an example of finite geometric sequence. Moving on with our next example, let us identify the first term of this geometric sequence. So the first term is -2. The common ratio, we can get that by dividing this to 6 divided by -2, which is -3. The last term is 486. So by listing or completing this one, we can write it as -2, 6, -18, 54, -162, 486. So we can actually count how many terms. 1, 2, 3, 4, 5, 6. So the number of terms is 6. So this one, again, is an example of finite geometric sequence. Since it has first term, common ratio, the last term, and the number of terms. Let's deal with the next example. So from infinity, we have 4, 2, 1, 1/2. So what is the first term? So we cannot determine our first term. How about the common ratio? We can have this 2, which is 2/4, or simply 1/2. So 1/2 is the common ratio. How about the last term? So the last term is 1/2. Number of terms cannot be determined. Okay? Since we can only determine the last term and the common ratio of the sequence, this one is an example of infinite geometric sequence. So the 3 dots or the ellipsis here tells us or indicates that the terms are continuous backward. Remember, Finite geometric sequence defines as a sub 1 times r, a sub 1 times r squared, a sub 1 times r raised to the third power up to a sub 1 times r raised to n minus 1 is a geometric sequence with a first term, common ratio, number of terms, or last term. On the other hand, infinite geometric sequence defines as a sub 1 times r raised to the first power, a sub 1 times r squared, a sub 1 times r cubed, and so on, has a first term and a common ratio, but no last term. The three dots tells us that the number of terms are continuous. Let's try this. Let us identify whether it is finite or infinite geometric sequence. Given 4, 20, 100, up to 12,500. If your answer is finite geometric sequence, then you got it right. Let us try another example. Given 2, negative 10, 50, negative 250, and so on. If your answer is infinite geometric sequence, great job! Until our next session, thank you and enjoy learning.